In this chapter, we're going to talk about acids and bases. Acids are represented by H plus, and bases are represented by an OH minus. The negative charge is on the oxygen because the oxygen has three lone pairs and it has one bond that is bonded to the hydrogen. This is a representation of a base, and it does have a negative formal charge. In general, acids, they run by the name Arrhenius acid. This is a general name for the acid. And bases, they run by the name Arrhenius bases. This is a general term for the base. So Arrhenius acids, these are compounds that when they are dissolved in water, they increase the concentration of H plus ions in the solution. So Arrhenius acids, these are acids that release H plus when dissolved in water and make the solution acidic. When HA, which is the representation of an acid, this is the general representation of an acid. So HA is a general representation of the acid. A can change, but the acids normally they start with a hydrogen. So this AHA is aqueous. This means that it is dissolved in water. It completely splits up. So this is splitting into its individual ions. We call it dissociation. The ability of HA to split up into ions determines how acidic is HA. So if the dissociation or the splitting up into ions is like 100%, meaning that all HA in aqueous solution splits up into ions and nothing of HA remains over here, then we would say that HA is a very, very strong acid. By definition, again, an Arrhenius acid is an acid that can release H plus ions in the solution, and this H plus is going to make the solution acidic. Let's have examples. So all of these are examples of strong acids: HCl, HNO3, H2SO4. The strongest is the HCl, and when you take HCl acid and you add water to it, HCl is going to dissociate into an H plus in there, aqueous, and a Cl minus, aqueous. So it's going to dissociate into its individual ions, and there will be no remaining HCl in the solution. All HCl will be dissociated into their individual ions in there. You can look and see what type of solution we did form. So the moment you look and see and you have like H plus in the solution, this means that your solution is acidic. So the concentration of H plus in the solution is going to be very high, making the solution acidic. Another name for H plus is a proton. So we call it a proton because it is plus charge. So hydrogen there, this is hydrogen ions or a proton. So any Arrhenius acid will dissociate into hydrogen ions or a proton, making the solution acidic, and the dissociation is going to be based on the strength of the acid. If the acid is strong, all HA will dissociate into its individual ions. If the acid is weak, then some of the HA will dissociate into ions and then the rest will remain undissociated. We'll have an example on that. HNO3, this is another acid that is going to dissociate completely into H plus and NO3 minus, aqueous. Notice that the charges, they have to balance. So we know that hydrogen is positive because it's a group number 1. NO3 is a polyatom, and NO3 has a negative charge. Plus, minus, they do balance out. Okay? H2SO4 is going to dissociate into 2H plus aqueous, right? Because after all, you have to balance the equation. So it's going to dissociate into H plus and SO4 2 minus, aqueous. This is the sulfate ion. Go to the polyatomic table. This guy is going to be a 2 minus. This is the sulfate. So definitely you need to balance it out, right? So to balance the equation out, you need to put 2 over there. And this is your balanced dissociation equation of an Arrhenius acid. All of these acids, we said that they are Arrhenius because they do start with a hydrogen and they have an A in there, which is the counter ion that balances the hydrogen. Arrhenius bases. So Arrhenius base is a substance that when it's dissolved in water, it increases the concentration of the OH minus in the solution. So basically, it's a compound that when dissolved in water, it releases hydroxide ion. So this is called OH minus is a hydroxide ion, making the solution more basic. So the presence of the OH minus will tell me that the solution is basic. The presence of the H plus will tell me that the solution is acidic. This is the general formula for a base, BOH. And B is normally a metal, like sodium, calcium in there. It can be a polyatom. It can be a polyatom. So this is the positive component of the Arrhenius acid. So B is the positive component of the Arrhenius acid, and the OH is the negative component of the Arrhenius base. So this one is the negative component. The negative component is always there in a form of an OH because the OH is an indication that I do have a base in there. Like, for example, sodium hydroxide. I know that the type of bond between the sodium and the OH, this is an ionic bond because this is between a group 1 and between an oxygen, which is group number 6. So this is going to be an ionic bond. All of these, they have to be ionic bonds in there in case of the base so that the dissociation can happen. In the acid, no, this is a covalent bond. So between the hydrogen and the Cl, because hydrogens, they make covalent bonds, okay? So between the hydrogen and the Cl, it is a covalent bond. I do have an H and the Cl. So this one over here is a covalent bond. The covalent bond is broken in this case, and then you form the individual ions. While in the case of the base, you do have sodium, Na, and then OH. This is not an NO, it's an OH, and the bond between them is an ionic. This is an ionic bond. It's an interaction in there because the sodium is a metal and the OH is a polyatom that has a negative charge, positive, negative. So there is no bond between the sodium and the OH. So when I take the sodium OH and dissolve it in the solution, then the sodium is going to turn into its individual ion, and the OH is going to turn into its individual ion. And again, you know how strong is your base by the dissociation. It's called the base dissolving in water or the base dissociation in water. So all of the base will turn into Na plus and the OH minus. Calcium hydroxide. So calcium is the group number 2. OH minus, this is a polyatom. So this is the formula for calcium hydroxide. And calcium hydroxide will dissociate. And again, you do have an ionic bond between both, no covalent. So calcium is going to dissociate into its individual ions because it's a group number 2. It takes 2 plus. Plus, you do have balance your equation every single time. So you do have the OH minus, and that is going to be aqueous. Ammonium hydroxide. So the positive component can be either a metal, you guys. So like in the case of sodium, calcium, magnesium, potassium, all of these are metals, okay? Or it can be in a form of a polyatom. Okay, here ammonium is a polyatom because I know that NH4 is what? NH4 is a polyatom, and it is positive. So this one acts as a positive component of the compound, And every time you draw any compound, any inorganic compound, you start with the positive part and then the negative part. Okay, so the negative, definitely it needs to balance. So I know that it is going to be an OH minus, it's a plus minus, so they do balance out. So you already have over here, this is going to turn into its individual ions. So it's going to turn into ammonium plus OH minus, and again, this is going to be aqueous. Okay, same thing, magnesium hydroxide. This is going to dissociate into its individual ions. So this is going to be Mg2 plus aqueous plus 2OH minus aqueous. So if I give you something like this and I ask you what type of solution is this, you always look at your product, you guys, and you see, okay, I do have an OH minus in my solution. So definitely my solution is going to be basic. Okay. Sodium hydroxide, this is going to dissociate into K plus ions plus OH minus ions. So definitely, again, my solution is going to be basic. So these are the two general term definitions of bases and acids. Bases, they do release OH minus in the solution. Acids, they do release simply H plus or a proton or a hydrogen ion in the solution.